Okay, ladies and gentlemen, what we are working on today is using elimination method to solve word problems. So this word problem starts out kind of strange. It says Farmer John has a farmhouse with 10 animals. We don't know why he's keeping the animals in his house, but we're going to go with it. Some of the animals are pigs and some are ducks. So this allows us to come up with some very creative variables that we can use. P for pigs, D for ducks. Since that first couple sentences helps us organize what we've got going on, that means we can actually come up with an equation for it. So we know there are pigs and ducks that total 10 animals. So your first equation is P plus D equals 10. Your next equation will be found if you read a little bit further. Altogether there are 36 legs in this scenario. So what you need to think about is that pigs have 4 legs, hopefully, and ducks have 2 legs. If there are 36 legs all together, this is where we use our variables again. 4 legs for every pig, 2 legs for every duck, add it all together equals 36. So what we have here is called a system of equations. Because your variables line up, I'm just copying that top equation down here so they're next to each other. And since the P's and the D's and the equal signs and the answers line up, we are going to use our elimination method. The problem with this word problem is, even though we transferred them into numbers and symbols very well, even though they line up very well, if we were to go and add these two equations together right now, we would not eliminate the P's or the D's. So that means we need to do a slight modification. We are allowed to multiply one of our equations by a certain amount. And the amount that you want to use, you have to think ahead a little bit. In this example, I could work on the P's. I have a positive 4P. I want a negative 4P, so I could be multiplying by negative 4. I think I'm going to work on the D's. So I have a positive 2. I want a negative 2 on the bottom. So that's what you have to think about ahead of time before you do your modification. So everything in this bottom equation gets multiplied by negative 2. Negative 2 times P, negative 2 times D, and negative 2 times 10. So my new improved modified equation is right here. My top equation with 4P and 2D is not going to be changed at all. It didn't need modifying. And the reason we do all this is so that we can now eliminate. So I'm drawing a big equal sign. I'm drawing a plus sign to remind myself I am adding these together. I am adding these together and they do eliminate. And then I am adding these together. So remember, elimination, even if it takes a little work up front, makes an equation that's much easier to solve. And right away we find out that P equals 8. There are 8 pigs in his farmhouse. Lucky him. Okay, so if there are 8 pigs, we have 2 equations to choose from. I'm going to pick the easier equation, which is much simpler than the other one. I'm going to pick this one, P plus D equals 10. If there are 8 pigs, of course there must be 2 ducks. So to show the math all fancy, you would have something that looks like this. Now if you're trying to write your answer as an ordered pair, remember ordered pair means you're writing in alphabetical order. D comes before P, so technically you would have the solution written like this. But even better is a sentence answer that says there were 8 pigs and 2 ducks. I'm going to advance my slide ahead. I did my check earlier, so this is where you can take both equations and you could fill in those answers that we just got. 8 plus 2 does equal 10. 4 legs per pig and 2 legs per duck does add up to 36 also, like you can see here. So even though it's a crazy example, I wanted you to have a way to use elimination to be able to solve a word problem using different variables that you write from the problem. Okay, moving on. We have a question about a pizza party. You're buying food for your friend's pizza party. You bought 3 sodas and 2 pizzas for 20 bucks. Later you realized more friends were coming, so your friend went to the store and bought 2 sodas and 4 pizzas. So I think just from reading that much you understand we need 2 variables again. Be careful using S for soda. You want to make sure when you write down an S it doesn't look like the number 5. P is pretty straightforward for pizza. And again, you're going to take each sentence of the problem one by one. So this is our first sentence. We need to convert that sentence into math, symbols, letters, and numbers. So there's our 3 sodas plus our 2 pizzas, giving us our price of 20 bucks. And I believe the friend sentence is right here. So this is where this information comes from. Your friend bought 2 sodas and 4 pizzas, and he spent 32. So once again, I have my 2 equations. I'm just going to copy this one down below this one so that they're next to each other and I can focus on what I've got. I do not have any matching variables, but I do have them lining up. So my S's are lined up, my P's are lined up, my answers are lined up. So I know I'm going to use elimination. What I need to think about is which one of these variables is going to be modified so that I have stuff canceling out or eliminated. I think the best place to work on this one is here. I already have a positive 4p, and I wish I had a negative 4p on the bottom. So can we easily turn a 2p, using multiplication, into a negative 4p? I think we're going to do what we did in the last problem. I think we're going to multiply by negative 2. So again, everything in this equation has to get multiplied by negative 2. That makes it the same value as the original equation, just looks different, and it suits our purpose. Remember, we're trying to use the elimination method. Oops, that's a 40. Check this, negative 40, negative 4 p's, and negative 6 s's. So I'm just copying the top equation over from before. The top equation did not need modifying. And then I'm going to bring my screen down so we can talk about adding these together. My 4p and my negative 4p cancel. That's how I designed it. These do add up to be negative 8, which is a little concerning, but if you think about the next step, we're going to be dividing by that negative 4. A negative divided by a negative is a positive. So sodas are $2. Let's see, if I have to choose an equation to work on, they're both equally complex, I think, so I'm just going to pick the top one. 2 sodas and 4 pizzas is 32. And I just found out that my sodas were $2 a piece. So 2 sodas at $2 is $4. And then with a little more work, we can solve for our pizzas. And I think I'm going to get 7. So 1, our answers seem reasonable. 2, we're going to plug it in and check. Let's see, S comes after P, so if I was to write this as an ordered pair in alphabetical order, it would look like that. Remember, I got my equations from the word problem. I had to do a modification again so that one of my variables would eliminate, and that's what's happening here. And then remember, once you get to this stage where they're eliminating, you will get one answer very quickly, and then use substitution to get your next answer. So here's the check. Remember, the original equations get written down. The answers you just got get substituted in. $2 for your sodas, $7 for your pizza, and you're just verifying that those sentences from the word problem really do make sense mathematically when you do the math.